Hello everyone, this is Mrs. Padmashri from SNS College of Engineering. This is my lecture video continuation of my previous topic backpropagation network. So previous video I explained about one of the working principle of backpropagation network, how the network is transmitting the data and how the error is calculated, how the error is formed, and if there is any error, how the data will be backpropagate to the input layer. This basic concept or the steps are explained in my first video, and this is my second video continued with the same back propagation topic. And here I am going to explain about the exact algorithm, how this network calculates the error and how the new weight and bias is added, and how we get the final optimal output in the back propagation. See, the main objective of this back propagation network is to find out the optimal solution for machine learning model. See, some model will be having error during the training process, and we need to just sort it out, or we need to find out what was that error, and we need to remove that error and improve the performance and accuracy of machine learning model. For that, its BPA network is very effective model, very effective network in artificial neural network. It just resolves the problem of error back propagated, and it solves and it produces the solution. So let's move on to the algorithm. The algorithm has only 4 steps: initialization of bias weight, and second, feed forward process, back propagation of error, updation of weight and bias. Here is the algorithm explanation. Initialization of weight. In the first step, we are going to initialize the weight value, which will be always the smallest random value to 0. And the second step, while stop condition is false, we have to repeat the step 3 to 10. And for the third step, for each training path, we need to continue with the step 4 to 9. So I'll be explaining what is the steps 3 to 10, 4 to 9. The second step, feed forward of input. So each input xi is received and forwarded to the next layer. As I said, I'll again show you the diagram here. The input layer is received here, and it will be feed forward to the next layer. Feed forward to the next layer. Okay. So the step 4, each input is received and forwarded to the higher layer. Step 5, the unit sum, its weighted inputs are as follows. That is, this will be the hidden unit sum. The hidden unit is at I and j, which is equal to the weight plus summation of input into weight. So WOJ is a weight, is a bias, which is going to add with summation of input into weight. See, each node will be associated with its input and the weight. The summation of xi into wj means we are going to calculate the input into weight for all the nodes and going to add with this bias value. By applying the activation function, zj is equal to, this will be the activation function, which is equal to f of z I n j. The activation function will be applied for each layer to check whether the particular node is active or not, whether the node is transmitting the data to the next layer or not. So this value will be passed to the output layer, and output unit sums, it's all the weighted inputs. So that is calculated as YINK, which will be in this YINK. I can say here, this is the output. Here we are going to calculate what is the value of YINK is VOJ, the bias added with summation of the second layer, second hidden layer is at Z input into the weight VJK. This is the second hidden layer. So for second hidden layer also, we are going to calculate the activation function of YK output, which is equal to a function of YINK. See, YINK is the previous, for this YINK is the second layer's output. So this is, you are going to calculate it. So the second, after the second step, we have the back propagation of error in step 7. So we are going to find out whether the forwarded output is having any error or not. So the error will be calculated as del k. Del k is equal to tk minus yk. So what is this tk? It is a target output minus yk is a predicted, or we can say it is a actual output. To find out the back propagation error, So this will be the formula we have is the del k is equal to targeted output minus the predicted, the actual output into the function of ink. Function of ink is the activation function, which is the output of the second hidden layer. So if there is any error, the error will be nullified by using this formulas. And the step 8 del inj is equal to summation of del j into vjk. So this is also the previous layers backpropagated error will be calculated with all the sum of all input into the weight. So after finding out the error, backpropagation error, updation of weight and bias is done here. So the weight and bias have to be updated. That is notified with the formula del wij is equal to alpha into del k. Del k, always we say del k is the error value, backpropagation error, into zj. Zj will be the output of the first layer. Say the bias also will be corrected and updated. The bias value is updated, bias is notified as del woj is equal to del k, alpha into del k, the error value. So the new weight and bias have to be added with the old one. So here error is found and the error is corrected and updated. And the next step, we are going to calculate the new weight and the new bias. How to calculate the new weight and the new bias is we need to add with the old weight and the updated value of each weight and the bias. Updated, you can take updation or corrected value. So the new weight is equal to wij of old weight plus the corrected, the updated del wij, which we have calculated here del wij. The same vjk, the second hidden layer, vjk new weight is equal to vjk old weight plus the corrected one del w del vjk. So this is how the new weight is calculated. And say the new bias has to be calculated. Bias is woj of new. Woj of new bias is equal to old bias plus del woj, the updated one, updated bias. So vok of new equal to vok of old. VOK is the second layer bias value. Second hidden layer's bias value is old bias value plus the updated bias value. So the new bias value is also calculated. Step 10, stop the condition. So until this has to be repeated from 4 to 9 for every input received from each layer, perceptron layer. See, here I have given the detailed explanation for step 7 and step 8. And the step 7 del k, we always say the del k is the error of kth neurons, tk target value, yk is the actual output, and function of y and k, we know this is the activation function is applied here. Same step 8 also, we have the input is summation of del, wherever we see del is an error value. So summation of all the del j, the error term from the jth output neuron into vjk is a weight calculator. So this how the error is back propagated and it is rectified and added with the new weight values. So the merits of this back propagation, it is very effective on rate correction, updation. The computing time is less and it is faster than the perceptron model, and weight updation is a systematic weight updation. So there is a drawback. We have a drawback here. It is a temporal instability. The network gets trapped for local minima value, and learning phase requires very intensive calculation. So these are the drawbacks. So thank you for watching my video. Keep supporting my videos. Thank you everyone.